So in the previous 4 videos, we've learned a lot about linear equations. We kind of learned what they were generally speaking. We learned about slope-intercept form. Then we got into point-slope form. And then after we learned point-slope form, we dealt with parallel and perpendicular lines. That's so much information that I thought it would be useful to make one additional video where I just kind of review everything that we learned. I asked questions that are as difficult as I could possibly make them to prepare you for any quiz or any midterm problem that you'll see this on. So this video will just be lots of practice. I'll break it up into 2 different sections, but really it'll just be one kind of long example. Without further ado, graph below is what I'm going to call line A. And from the graph, we can see that line A passes through the point -3, 4 and the point 1, -6. It's hard to tell what its y-intercept is. It appears to be some number between -3 and -4. And it's not immediately obvious what its slope is, although I think we can calculate it fairly easily, but it's got some negative slope because this line goes down when we look at it from left to right. The first thing that we're asked to do is find the point-slope form of this line. So let's see, point-slope form. Oh, right, that's y minus y1 equals m times x minus x1. Don't confuse this with slope-intercept form, y equals mx plus b. The reason I didn't ask you to find the slope-intercept form of this line immediately is because it's not obvious what the y-intercept is. You might guess it's -3.5, I think it is, but you don't know that just by looking at these points. So point-slope form. To use point-slope form, we need to know the slope of the line. To figure out the slope of the line, you can either think about it as rise divided by run, or kind of more formulaically. I think I'm going to do it more formulaically. I'm going to say that the slope is always the difference in the 2 y coordinates divided by the difference in the 2 x coordinates. And it's up to me which of these points I call the first point and the second point. It doesn't matter at all. So I'll arbitrarily pick this one to be my first point. So x1 is equal to -3 and y1 is equal to +4. Since these are my 1s, these are my 2s. So x2 would be +1 and y2 would be -6. Taking these 4 values and plugging them into my slope formula up here, in the numerator I have -6 minus 4, and in the denominator I have 1 minus, careful, -3. So let's see, -6 minus 4 more leaves me with -10, and -1 minus -3 is the same as -1 plus +3, which is 4. -10/4 is my slope, although typically you don't leave it this way. Typically you reduce this fraction and rewrite it as -5/2. We can sort of double check that. If the slope is -5/2, it should go down 5 units, 1, 2, 3, 4, 5. Each time it goes right by 2 units, 1, 2. Oh yeah, that takes me to another point on my graph. Nice. Now that I know the slope, I just use either of these 2 points. It doesn't matter which one, but it might be less confusing to use this point since I've already called that x1 and y1, and plug this value and these values into this equation for m, y1, and x1 respectively. So I would have y minus 4 is equal to -5/2 times x minus -3, in other words, x plus 3. If the question asked me to find point-slope form of the line that's pictured, which I think is exactly what part A is asking me to do, I'd be done. For part B, I'm going to take this answer from part A, and I'm going to use that to figure out the slope-intercept form of this line. So I'll take y minus 4 equals -5/2 times x plus 3, and I'll just solve it so that it looks like y equals mx plus b. Remember, the slope-intercept form is just y equals mx plus b, not to be confused with the point-slope form, which is the y minus y1 equals m times x minus x1 that we use down here in red. Anyways, to go from one to the other, it's pretty easy. I'm just going to solve this equation for y. As we've seen a couple of times now, it's easiest to do so if I first distribute this slope into these parentheses. So I would get y minus 4 is equal to -5/2 times x plus whatever -5/2 times 3 is. Well, let's see, a negative times a positive is going to be a negative number, so I'll be subtracting. And then 5/2 times 3, if you think about this, 3 is 3 over 1. 5 over 2 times 3 over 1 is the same as 15 over 2. I'm not quite done. Now I need to add 4 to both sides of the equation. So I get y equals -5/2 x minus 15/2 plus 4. But maybe instead of writing plus 4, I'll write plus 8 over 2. Because I'll first think about that 4 is 4 over 1. And then I'll multiply the top and the bottom by 2 so that I have a common denominator, so that I can add these 2 things together and get my final slope-intercept form of y equals -5/2 x plus negative 15 halves plus 8 halves, and negative 15 halves plus 8 halves is negative 7 halves. Here's my answer for part B. It's kind of nice that we can check this answer. We should have the same slope as we had before, yet still negative 5 halves. And this is saying that the y-intercept is negative 7 halves. That's what, negative 3.5? Oh yeah, that looks like what the y-intercept is in the picture down here. Nice. All right, everything I've done so far has dealt with this line, which is what I'm calling line A. But now what I want to do is I want to talk about a different line, which is what we're calling line B. And the idea with line B is it's similar to line A. In fact, those two lines are parallel. The only difference is that line B is going to pass through the point negative 1, 6. So if you want a geometric interpretation of what's going on, negative 1, 6 is talking about this point right here. And I want to draw a line that's parallel to this one in red that passes through this point. So I guess it would look about like this, pictured in green. What I'm supposed to do in part C is to algebraically determine the point slope and slope intercept forms of this line that's shown in green. So really I shouldn't have graphed it first. I should be doing all of this without the graph. I'll leave the graph there just to help you visualize stuff, but I want to emphasize that I don't need the graph at all to come up with the slope intercept or the point slope form of this line that's pictured in green. All I'm going to do is follow the same steps that I did in red, except with different points. So first I'll figure out the point slope form by taking y minus y1 equals m times x minus x1 and plugging in the appropriate values for x1, y1, and m. Do I have all those values? Yeah, I think so. It told us that it passes through the point negative 1, 6. So x1 is negative 1 and y1 is positive 6. So I would have x minus negative 1 or x plus 1 here. And I would have y minus 6 over here. The only piece of information that's missing is m, the slope. However, even though I'm not explicitly told what the slope of line B is, I am told that it's parallel to line A, and I already know the slope of line A is negative 5 halves. So therefore, because parallel lines have the same slope, the slope of line B is also negative 5 halves. And I'm done. I have the point slope form of line B. Oh, but I don't just want the point slope form, I also want the slope intercept form. No problem. Just solve this thing for y. Take the negative 5 halves and distribute it through the parentheses. I got y minus 6 equals negative 5 halves x minus 5 halves, which I get this extra negative 5 halves from this negative 5 halves times this positive 1. And then add 6 to both sides of the equation. Y equals negative 5 halves x plus whatever I get when I add negative 5 halves and positive 6. Well, let's see. Positive 6 is the same as 12 halves, and 12 halves minus 5 halves is 7 halves. So the slope-intercept form of line B would be y equals negative 5 halves x plus 7 halves. It should have a slope of negative 5 halves and a y-intercept of 7 halves. Let's see, 7 halves, that's like 3.5. Oh yeah, there it is. There's that y-intercept. And from this point, I want to go down 5 units. 1, 2, 3, 4, 5. Each time I go to the right 2 units, I guess this would be another point on my line. And sure enough, it does line up. Line B is parallel to line A. Part D kind of asks about the leftover stuff, the x and y intercepts of line B. One of those is really easy. One of those just involves one step. To figure out the y-intercept, well, because I already have slope-intercept form, the y-intercept is just 7 halves, the value of b in this equation. I'm done. To figure out the x-intercept, what I'm trying to figure out is the point at which my green line crosses my x-axis. It looks like it's whatever this value is right here. Hard to tell from the graph, but this purple dot has a height of 0. It's not above, it's not below this x-axis. It's right on the x-axis because it's the x-intercept. So because its height is 0, all I got to do is change the y value into 0 and solve for x. So to figure out the x-intercept, I'm just going to solve the equation 0 equals negative 5 halves x plus 7 halves. To solve this equation, maybe I'd add the 5 halves x over to the left side. I get 5 halves x equals 7 halves. And then you can think about it as I'm dividing both sides of the equation by 5 halves. But I think it's easier to think about it as we're multiplying both sides of the equation by 2/5. So what I would end up with is x is equal to 7 halves times 2/5. And you can multiply these fractions straight across if you want and call it 14/10. Or you can cancel out these 2's and reduce that fraction to 7/5. The x value, when the y value equals 0, aka the x-intercept, should be 7/5. Let's see, 7/5 is a little bit more than 1. It's 1 and 2/5. Oh yeah, there it is, right between 1 and 2 here. It looks like that matches up on my graph. The final thing that I was supposed to do here is to use the slope-intercept form of line B, this y equals negative 5 halves x plus 7 halves, to come up with the graph that's shown in green. But I think I already did that. I just kind of did things out of order. And then once you have this graph, you can verify the x and the y intercepts and make sure they show up about where they should based on the calculations we did. But I've already done that as well. I probably could call this video good here, but in the interest of showing you everything that we learned, or at least as much as possible in these videos, I want to do 3 more parts. I want to talk about a third line, which I'm going to call line C. And line C is a lot like line B. It's also related to line A. The only difference is now instead of being parallel to line A, we're going to be perpendicular to line A. So as a reminder, line A in its slope-intercept form was y equals negative 5 halves x minus 7 halves. And since we're so good with slope-intercept form, we can just look at this and tell the y-intercept and the slope immediately for line A. I don't want the y-intercept and the slope for line A. I want to know the y-intercept and the slope for line C. Fortunately, I can use what I know about line A and the information that's given to figure that out. So for line C, we know it goes through the point negative 1, 6, and we know its slope because it's perpendicular to line A, so its slope is the negative reciprocal of negative 5 halves. So instead of being negative, now it's going to be positive, and instead of being 5 halves, now it's going to be 2/5. I know one point in the slope, so I can get point slope form, which I can then turn into slope intercept form, and then I can be done. Point slope form is the y minus y1 equals m times x minus x1. So I can plug in negative 1, 6, and 2/5 for x1, y1, and m respectively, and get y minus 6 equals 2/5 times x minus negative 1, in other words, x plus 1. Here's the point slope form of line C. What about slope intercept form? Well, that's easy enough. Just solve this guy for y. So I first take this 2/5 and distribute it through the parentheses. Y minus 6 equals 2/5 x plus 2/5. And then I add 6 to both sides of the equation. I get y equals 2/5 x plus, let's see, 6 over 1 is the same as 30 over 5. So I would have 30 over 5 plus 2 over 5. I would have 32/5. Here's the slope-intercept form of line C. Algebraically determine the x and y intercepts. Well, the y-intercept is really easy. The y-intercept is given from slope-intercept form. It's this 32/5. For the x-intercept, I just have to solve this equation. I have to figure out what x must be equal to when y is equal to 0. So I get 0 equals 2/5 x plus 32/5, and then maybe subtract 32/5 over to the other side, and multiply both sides of the equation by 5 halves, and I'll get x is equal to negative 16 when all the dust settles. If you have a hard time following that, I kind of picture the 5 up on the top here and the 2 down on the bottom, and the 5s cancel out, and 32 over 2 reduces to just 16, and a negative divided by a positive is a negative. I got the y-intercept and the x-intercept. Now I can try to graph this line and sort of verify the intercepts, at least as best I can. I think some of them won't even show up on the graph. Let's see, to graph the line, I guess I could use the slope-intercept form, y equals 2/5 x plus 32 over 5, but I kind of don't want to use this form because I don't want to have to find 32 over 5 on my graph. That might be hard to do. Maybe it's easier to graph this guy using point slope form. Point slope form tells me that the slope is 2/5, and this line passes through the point negative 1, positive 6. So here again is negative 1, positive 6. This point fell on line B. It also falls on line C. But now my slope is positive 2/5. So from here I'm going to go up 2 units. Each time I go to the right 5 units. 1, 2, 3, 4, 5. That brings me over here. And I'll connect these guys with a straight line. We can verify the x and y intercepts, or at least get a good idea of them. The y-intercept was supposed to be 32/5. 32/5 is just a little bit more than 6. Yeah, that checks out. And the x-intercept was supposed to be negative 16. If you continue this line, maybe you can see that it would cross this axis around negative 16. So you're like, cool, we're done. Well, one thing might cause you a little bit of trouble. When you stare at these graphs, it doesn't look like line C is perpendicular to line A. Don't worry, they actually are. The reason it doesn't look like they're perpendicular here is because the scales are skewed a little bit. If you look at the distance that you have to go to travel 1 unit to the right, it's different than the distance that you have to go to travel 1 unit up. So because these axes were scaled to get this graph to show up, it doesn't look like these guys are perpendicular, but really they are. I think we're all done with this problem and therefore all done with this video.